After uploading the conceptual video lecture on junction FETs, the solution of two related gate problems has been taken up, and both the problems are on junction field effect transistor amplifiers, and these problems are of gate 2005 and gate 2002. So we start with the problem of gate 2005. We'll read out the problem first and then see what all is to be done here. Gate 2000, this is a common data type of question, and basically consists of three parts. The given parameters for the circuit as shown here are like the RD drain resistance given to be 20 kilo ohms, IDSS is 10 milliamperes, VP is minus 8 volts. Number one, first part is ZI and Z0 of the circuit are respectively. So we have to find the ZI and Z0 for the circuit. Okay, then these are four options being given here, and we have to see which is the right option. Now the second part is you have to find out ID and VDS under DC conditions, and there are again four options here, and we have to find the appropriate choice, which is the best choice here. The third part is transconductance in millisiemens and the voltage gain of the amplifier are respectively. Again these options are given here, and we have to find out which is the right option here out of these. So this problem is basically on the based on the FET junction FET amplifier, and so all these three parts together more or less gives us all the performance parameters of FET amplifier. It's a very simple problem, and it's only of substitution type, where you could directly substitute the values and get the results. Here for the first part we have to find out the ZI and Z0 for the circuit. The circuit is known. You can again see the circuit. This circuit is here. In this circuit we observe here this is an FET where the drain resistance 2 kilo ohms is put into this to the drain, and this is the base bias circuit having a base resistance of 2 mega ohms, and these are the ZI and Z0 values. This means the input and output impedance of the circuit. Okay, so we start here. ZI, we see ZI, basically ZI is the 2 mega ohms. This is the bias resistance value, and since the input impedance for FET is very high, so the ZI will come out to be about 2 mega ohms in parallel with the very high resistance, that will be 2 mega ohms only. So the value of ZI is 2 mega ohms. Now Z0, the output impedance, that is the drain resistance RD in parallel with the resistance value RD put to the drain resistance here, that is 2 kilo ohms. So RD in parallel with the resistance put here. There is no load resistance being put here, so this would be RD in parallel with RD, that is 20 kilo ohms in parallel with 2 kilo ohms, this 20 by 11 kilo ohms. So here option B is the right choice for this. Now For the second part, we have to find the ID, the drain current, and the VDS value, drain to source voltage, and this we have to find for the DC conditions. We know the value for drain current is given by IDSS, 1 minus VGS over VP whole squared. IDSS is given to us 10 milliamperes, 10 to the power minus 3, 1 minus VGS minus 2 volts. This is pinch off voltage is minus 8 volts. So this comes out to minus 2 minus 8 whole squared. This comes out to be 5.625 milliamperes. Now the VDS is VDD. You can find here VDS. We have to find this VDS. This VDS will be VDD minus the drop, because this 2 kilo ohm resistor. Okay, so this is VDS is VDD minus IDRD. VDD is 20 volts minus IDRD 5.265 milliamperes. We already find into value of RD is 2 kilo ohms. It comes out with 8.75 volts. So this option A is the right choice here. Now if you see part 3, we have to find GM and the voltage gain. The value for GM you can find through this relation, twice by VP magnitude IDSS. So this 2 by 8, 5.62, all the values are known to us. This comes out to be 1.875 millisiemens, and the value of gain we can find, that is minus GM RD in parallel with RD. So this comes out to be minus GM and RD in parallel with RD. So this 20 by 11 K. So this comes out to be gain of minus 3.41, and that corresponds to option B in this. So all the parts have been done, and what we observe here is all the related FET parameters have been evaluated in this, and this is a very good illustrative problem which gives you an insight for the common source kind of FET amplifier, and what are the approximate values of these parameters like the gain and transconductance. You observe here that the gains for the voltage gains for FET amplifiers are normally much lower than the voltage gains of BJT amplifier, which you already seen. So here you get a gain of 3.41. So this is the solution to this problem. Thank you.